Hello, in this screencast I'm going to solve some of the problems related to radical equations and graphing radical functions. In the first problem here I have a square root equation and I'm always going to solve that by, if it's not isolated already, isolating the radical on the left side of the equation. In this case it already is, so I'm going to proceed and square both sides of the equation. Because when you're having a radical equation, involving square roots, it means the index is 2, and you always raise both sides to the same power as the index. That's going to cause the radical on the left to drop out, and on the right I'm going to have to FOIL. And when I FOIL, I'm going to get m squared minus 6m plus 9. Now I'm going to have a quadratic equation that I need to solve by factoring. And to do that, I need to move everything to one side of the equation. So I'm going to have to subtract 7m and add 27. Those drop out. Those drop out. Now I have m squared minus 13m plus 36 equals 0. Now I need two numbers that multiply to be 36 and add up to negative 13. Well, that's 9 and 4. That means my solutions are m equals 9 or m equals 4. At this point I need to check to make sure that neither of those is extraneous. So when I take 9 and I put it back into the original equation, I get 63 minus 27, which is 36, and the square root of 36 is 6. And when I put 9 on the right, I get 9 minus 3, or 6. So that checks out. Now let me take 4 and put it back in, and I get 28 minus 27 is 21, or is 1. Take the square root of that, you get 1. And when you put 4 in on the right side of the equation, you also get 1. So that does check out. Now, when I put the value in for the variable, if the right side of the equation had turned out to be a negative number, that would have been an extraneous solution, and I would have discarded it from the solution set. So I'm all finished, and I have two solutions for this equation. Now, in the next problem, I have the fourth root. So I know I'm going to raise things to the fourth power, but before I do that, I need to isolate that radical on one side of the equation. So I'm going to do that by dividing by 3. So now I have 3 equals the fourth root of k minus 22. Now I'm going to raise both sides of the equation to the fourth power, and that's going to give me 81 equals k minus 22. Then I add 22 to both sides, and that gives me 103 equal to k. Now if I put 103 back into the problem, I get 81. 9 equals, 9 equals 3 times the fourth root of 81. Fourth root of 81 is 3. 3 times 3 is 9. So that checks out, and I have a real solution. All right, now I have a square root function to graph. So to do that, I always start by graphing the parent function, which in this case is going to be y equals the square root of x. So I want you to do 0, 1, and 4 in your table of values. And when I put 0 in for x, I get 0 for y. When I put 1 in for x, I get 1 for y. And when I put 4 in for x, I get 2 for y. So my points then are 0, 0, 1, 1, and 4, 2. And now I need to decide what my shift is going to be. So to decide the shift, I like to move the constant that's over by itself over to the other side of the equation. So that's going to give me y plus 2 equals the square root of x plus 3. Now I'm going to look at the 3 and the 2 and decide what they mean for my shift. Well, 3 a positive 3 for x means shift 3 to the left, and a positive 2 for y means shift 2 down, because it's the reverse of what it would be otherwise, or what you would think, given the positive and negative directions for x and y. Okay, so now I go to each point on the parent function. Oops, and it looks like I forgot to actually connect the dots to make the curve for the parent function. Alright, so now I'm ready to shift each point. So I go to my 3 points and I follow the directions. 1, 2, 3, 1, 2. That's the first point. The second point, 1, 2, 3, 1, 2. And the third point, 1, 2, 3, 1, 2. So my shifted function is that. That's the shifted. That's the parent. And the domain and range of the shifted function, well, those would be x greater than or equal to negative 3 and y greater than or equal to negative 2. Now if you look at the back into the shifted equation here, I see I have a 3 beside the x and a positive 2 beside the y. You actually use the opposite of those numbers as the domain and range, because once again the domain is the region of the graph where, or the values for x where the curve exists, and the domain, I'm sorry, let me say that one more time. The domain are all the x values that will produce a y value. In other words, which x values is the curve defined for, and the range are all the y values that can result from substituting in a value for x. Alright, I hope you found this helpful. Hopefully someone will be watching it, and we'll see you tomorrow. Cheers.